Okay, let's try a couple of examples. We have a few types. So this first type, example A, I always want to check, is it solved for 0? Yeah, my equation is already solved for 0. So that means it's already factored. I can set the two pieces equal to 0. And we're going to solve. Adding 2 here, x equals 2. Subtracting 5 here, x equals -5. These would be the two solutions. Same thing over here. If I wanted to solve, how do I get x by itself? I add 6. How to get x by itself over here? Dividing by 2. Those would be my two solutions. Now, after that, it gets a little bit more complicated. So if I'm looking at example C, do I have a greatest common factor? I don't, so I have to use the AC method. The AC method says I'm going to use 1, because that's A, times 24, which would be 24. Listing multiples of 24, I have 1 and 24, 2 and 12, 3 and 8. I'm looking for the set that gives me -11. If I change this to -3 and -8, that gets me -11. So I'm going to break that up to -3x and -8x. We're going to add 24 to the end and x squared to the beginning. Group them together. My greatest common factor here is an x. Greatest common factor here is -8. Now they have the same thing in the parentheses, so I'll factor that out. And I'm literally just going to write what's left. Okay, so now that I've factored, I have to set both pieces equal to 0. Ooh, that did not transfer well. Let me erase that. There we go. And solve for x. So I'm adding 3 here. X equals 3. Here I would add 8. Those are my two solutions. I'm going to go down to example E. Example E, I only have 2 terms. So this is a difference of squares. Or I'm going to look and see if it's a difference of squares. Is there something that I can square to get me x squared? Yep, that's x. Is there something I can square to get me 64? 8. So it is a difference of squares, so I follow the pattern. X minus 8 times x plus 8 equals 0. Set them equal to 0. And solve. X equals 8. X equals -8. Those are my two solutions. Okay, let's try example G. Example G has 2 terms, but is this a perfect difference of squares? Well, x times x is x squared. Is there anything that I can multiply by itself to get 3x, though? Nope. So here, this must be a greatest common factor. The greatest common factor would be an x. Now I'm going to set both pieces equal to 0. So I'll have x equals 0, x minus 3 equals 0, and we'll solve. This one's already solved. Here I'll add 3. There's my second solution.